Here we have quite a tricky problem-solving question using probability. So you won't have come across a question like this before. That's why they've put it on the paper to see, basically to watch you squirm. So just 7 marks with very little in the way of help or scaffolding. Now it's talking about an x-axis basically. So draw one. If you didn't draw one, you probably struggled to imagine what was going on in this question. So let's draw an x-axis and just think about what's happening. If we start here, if we throw a heads, we move left. If we throw another heads, we move left again. We might then throw tails and move right one. We might then throw another heads and then 2 more heads, and we'll end up here at -4. So we just do it 6 times. So let's just, yes, in each flip of the coin you're either going to get heads or tails. But let's think, where have we heard this before? You carry out a trial and you either get one thing or another. Heads or tails, success or failure. This is binomial. We don't need the normal binomial process to actually solve this. I'm going to show you a quick way, and then I'm going to show you the proper way using binomial, which they actually expect you to do, what the examiner will be looking for. But you'd get the marks for the quick way as well, because it's valid. So let's just look at the different scenarios here. The number of heads, I'm going to call a head a success. Equally, you could set this problem up using tails as a success. Now, how do we get no heads? Well, that requires tails, 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 and that's going to make us end all the way over here. Well, how many ways are there of doing that? There's only one way of getting all tails. How many ways are there of getting 1 head and 5 tails? Well, that's 6C1, which is 6. That particular heads that we get could be any of the 6 flips, and there's 6 flips. And then it gets a bit more complicated, but it's just 6C2, 6C3, etc. How many ways are there of getting 2 heads, 15, 3 heads, 20, and etc. So that's the number of ways of getting each of those results. And the thing to spot that makes this quicker is that all of these outcomes are equally likely. So to get, say, head, head, tail, 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 tail is exactly the same probability as getting tail, 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 tail. It's just there's 15 ways of getting 2 heads. So you could equally get tail, head, head, tail, tail, tail. And that way is equally likely as well as getting 6 tails. And because these are all equally likely, we just care about how many ways there are. That's all that matters here. The distance is something you need to think about though. If we get no heads, then we start here and we end there at -6. So our distance is 6, the final distance it wants. So we'll be 6 away if we get no heads. If we get 1 head, well, let's go tail and then head, 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 head. We're going to be at -4, so 4 away. And you can quickly spot that if you get 2 heads and 4 tails, you end up 2 away. If you get 3 heads and 3 tails, you end up at the origin. And we get a symmetrical set of numbers for 4, 5 and 6 heads. So the question actually just comes down to which is the most popular. Well, there's 30 ways of getting 2, sort of ending up 2 away, because there's 15 from 2 heads and 15 from 4 heads. But there's only 20 ways of staying in the middle. So 30 is bigger than 20, also bigger than 6 plus 6, which is 12. So there's your answer. The answer is just 2. 2 is the most probable value of D. Now if you found that a little bit abstract, that's because I suppose it was. So here's a proper use of the binomial to solve it. I'm going to define x as the number of heads. And we get somewhere from 0 to 6 heads as we've already seen. So x is binomially distributed, 6 trials and a half chance of success in a single trial. but we need to consider all the different probabilities. Now you can use your ClassWiz calculator to calculate all of these in one go. When you go into binomial PD mode, don't go into list rather than variable. And for the possible x values, type in 0, enter 1, enter 2, enter 3, enter 4, enter 5, enter 6. When you press enter for the next time, it should take you back to the sort of menu where you can type in the parameters, N and P. Sorry, yes, N and P, that's right. So if you do that, you get this long list of probabilities, which you might spot are symmetrical again, which we'd expect that. So we've got this 0.3125 in the middle, but either side of that we get the same probabilities. Then it might be a good time to think about the distance, but we did that over before, so I can just copy those values over. And then you just need to sort of add up the probabilities for the 2s and for the 4s and the 6s, etc. Now this time I've done a special table, a different table. So those are my 4 possible differences, 0, 2, 4 and 6. The probability of ending up in the middle is just that one there, 0.3125. But the probability of ending up 2 away is the sum of these 2 probabilities, which gives us that. If you add up these 2 probabilities, you get 0.1874, and if you add up the 2 on the end, you get 0.0312. And it's very obvious then that the most likely value of D is 2.